Hi, and welcome to this edition of Tech Talk Thursday. I'm Leander from QAware, and I'm happy to be your host. Today, we're going to talk about using application class data sharing to boost your Jakarta EE application startup time. I got this idea from one of my recent projects. I've prepared a small demo application for you, and if you want to follow along with the code samples I'm going to show you in a second, then make sure you clone this GitHub repository. Okay, let's look at some code. Everything I'm going to show you and I'm going to explain you is, well, pretty much inside this README file here. So if I'm too quick for you, then, follow along using the README file. Inside this repository is a very small Jakarta EE web application, okay? It's a small microservice with a small REST API. You see all those files here. There's nothing special about this. Now, if you open a terminal, the first thing you should make sure is you use a JDK 11. I'm going to use Zulu JDK for this demo here. So make sure you compile everything. Now if you start up this application without application class data sharing, I'm going to do that in a second using this command here, you will see that the time it takes to spin up this application is quite significant, right? Let's see how long it takes. It's about 12.3 seconds, okay? That's quite a long time. Now let's see if we can improve this time. And this is basically one of the main reasons and purposes of application class data sharing. Application class data sharing is basically giving the JVM a serialized version of all the classes it needs to load so that the JVM spins up a lot faster. And as an added bonus, the JVM will also be able to, memory map this file, so the amount of native memory used by the JVM will also be a lot lower than compared to without application class data sharing. Now for this to work, you have to, issue a few commands. The first thing that's slightly tricky is, for application class data sharing to work, you need a stable class path. Now if you work with Payara, like I do in this case, you can issue the following command to output a so-called launcher. And that is basically take an uberjar and extract it into some directory. So what we have here is we have this root directory here, and that's kind of the extracted uberjar. And this is kind of dependent on the runtime you're going to use. And this will probably also work with a Spring Boot application. Now having that, the next thing I need to generate is a list of the classes my application is going to load when it starts up. And this is what this command is going to do. So I say java -xx dump loaded class list. I give it a name, and then I give some commands to fire up my application. And once the application is firing up now, for every class that it's loaded, this class will be output into my class list file as specified. So now I have a class list file here in this directory. If we have a look at this one, you see that, it's basically in every line there is the class name that has been loaded. And overall, if you put this overall, you see that it's 15,183 classes been loaded. Now using this loaded class list file, I can now generate the shared archive file that is required for application class data sharing to work. So I say java -x share dump. I specify the shared classes file I generated in the previous command. I also specify the name of the shared archive file to generate, and then I fire up the application. Now this command is going to take a while. So it fires up, it takes as an input the shared loaded class list file, and then it kind of records all the metadata of the classes that have been loaded by the JVM. Now while that is running, if you happen to use Java 13 and onwards, those two commands can be, well, reduced to just one single command. And this is what is shown here in the README file. If you have Java 13, what you can say is, well, -xx archive classes at exit, and then you specify the name. So the recording of the loaded class list file plus the dumping of the shared archive file is well condensed into one single command, and that's kind of neat. Now we're almost done now. As you see here, it's the final phase of, you know, creating this shared archive file on the console. And now I see here there is this payara.jsa file, and it's 160 megabytes big. Okay, so this is all the metadata and all the, well, serialized version of the class metadata that is required by the JVM, well, to load all those classes. So let's issue the following command, java -x share run. So we say please use sharing. We pass it the shared archive file, and we fire up the application. So let's see what's happening now. So again, the application spins up, but instead of more than 12 seconds, it's only 8 seconds now to spin up this application. So the amount of time it took to spin up this application has been reduced quite significantly. Now, of course, what I just showed you on the console is, you know, probably not the use case you would use in production. Instead, what you would use in production is, well, you would use a, well, container to run your application. So I've prepared two Docker files for you. The first Docker file is basically, you know, building in the first stage the application, and then in the second stage it's well, basically using the output from the first stage, and then here in this final run command it's exactly, well, issuing those commands I just showed you in the console. Okay, so what we're doing here is create this shared archive file within our Docker build. Okay, so we have a final image that is optimized for application class data sharing. And here in the entry point parameters, you see that we're using this shared archive file to fire up the application. Now let's see. So let's go to this console here, and, well, if you make the first image, this is the image created without application class data sharing. And we can also issue the second command to create the image with enabled application class data sharing. So we have two images now. So you see here. So the first thing you notice is, of course, the one here, that's the image without application class data sharing, is 294 megabytes. And the image with application class data sharing is 514 megabytes. So of course this image is slightly bigger due to the shared archive file. But if I run this stuff, so let's run the default image here, and let's see. So I spin up the default image without application class data sharing now. So it took 8.3 seconds and the memory usage is 350 megabytes about, okay. And I will do the same with the application class data sharing enabled image now. So I will run this one. So it will spin up in under 5 seconds, so 4.8 seconds. So you see here also a significant reduction in startup time. And if you look at the memory usage, it's also significantly reduced to 270 megabytes. And this is kind of the main benefit exactly if you run in a containerized environment, okay? So your applications will start up a lot faster, and the amount of memory they use and the amount of native memory they use will also be significantly reduced, right? And this will work pretty much for every Jakarta EE application and also for any Java application. So if you're in the Spring Boot world, this will also work, you know, for you and also speed up your applications. Okay, that was it for this edition today. Make sure you follow along and stay connected either on SlideShare or you get along with our YouTube channel and you follow on Twitter, so you know when I'm going to publish the next video. So for today, thanks a lot for listening. Bye bye.